Using chemigation can be a great way to reduce nutrient input costs, improve a crop's nitrogen use efficiency, and when done properly, can help reduce the leaching of nutrients into groundwater systems. However, injecting chemicals into any irrigation system comes with inherent risks, and the proper safety devices must be used and properly maintained. Each summer, the Lower Loop NRD staff work with producers to conduct over 1,500 safety inspections on active chemigation permits. This video will go over the purpose of an irrigation line check valve system, examine what features NRD technicians are inspecting, and show examples of its proper and improper function. Here is a basic example of a check valve system. The valve is located between the source water, generally a groundwater irrigation well, or surface water such as a canal, and the chemical injection point. In the case of groundwater wells, the check valve should be the first in-pipe device in the system to reduce contamination risk. The check valve gate is held closed with a system set to a tension creating a watertight seal. Once the irrigation pump is turned on, water will flow toward the check valve, and the vacuum relief valve should raise to a close as the pressure builds in the line. Water will build on the check valve gate until the pressure can surmount the tension of the spring system holding the valve closed. Once the pressure has surmounted the spring tension, the check valve gate will swing upward and allow water to flow into the irrigation system. The source water will be mixed with the chemicals to be applied at the chemical injection point. The irrigation system is now operating, and chemically mixed water can now be distributed via the irrigation system onto a crop. Chemigation can occur through a gravity system, pivot, or subsurface drip, though center pivot is by far the most common irrigation system. When the system is finished irrigating and the pump is shut off, pressure will immediately recede. The vacuum relief valve should fall open. This prevents a vacuum from forming and siphoning chemicals back toward the source water. Once the pressure is no longer greater than the spring tension at the check valve gate, the valve closes, preventing any mixed water from returning to the source. With the valve closed, a watertight seal is created and prevents the backflow of chemically mixed water. The system should also have at least a 3/4 inch low-pressure drain composed of corrosion-resistant material. The low-pressure drain, located on the underside of the valve, begins draining away any water left in the check valve. Since the low-pressure valve is intended to drain any seepage that is making it past the valve gate, the valve should be hooked up in such a way that the water will drain to a spot at least 20 feet away from the water source. The next clip demonstrates the startup of a properly functioning check valve. Externally, all you'll see is the vacuum relief being pushed into place. The next clip demonstrates the shutdown of a properly functioning check valve. Note that the hose is removed from the low pressure drain only for demonstration purposes.
You can look down and see that it's not good.
And here are some examples of check valves that are not functioning properly. In each of these clips, the pump is shut off and the water you are seeing is heading back towards the source. Thank you for watching this video. For more information on chemigation or to apply for a chemigation permit, you can visit our website at www.llnrd.org.